Yes, so please welcome back. Due to things, we are back a little earlier, so we want to complete the digital computer design, right? Excellent. So where we got to was me teaching you the various parts. Now we're about to talk about how it all fits together in designing sequential circuits. You understand? So please be on standby. Beautiful. So the question we are going to be working with is this, right? I hope you can all see it on your screens now. Right. This is the question that we are going to be working with. Right. A sequential circuit has three flip-flops, A, B, and C. One input X in and one output X out. Right. So from this one, we'll be able to tell a number of things, right? So we have so we have three flip-flops, right? A, B, and C, right? Meaning that if you remember what I said about the states and the number of flip flops needed, if you need three flip flops, that means that the maximum number of states we can have in our system is 2 raised to the power 3, which is 8. Excellent. So we can continue reading the question, right? One input X in and one output X out, meaning that there's a different question than what we've seen so far, right? So far we just want to change states. Right now we have an input X in and Y out. You understand? It will change the way we analyze the circuit. So let's see how that happens, right? The state diagram is shown in this one. So this is the state diagram. Right? This is the state diagram. This is the state diagram. You can have a look at it. Very, very good state diagram. Interesting. Right. The circuit is to be designed by treating the unused states as don't care conditions. You see, this is very, very important because we just found the number of states 8. But if you look at the state diagram, you'll notice that no, go back. You'll notice that we have one like 0, then we have 1, then we have 1 0, then we have 1 1, then we have this one, right? So we have 5 states in total, but we can have 8, meaning that three states equals don't care conditions. Beautiful. Let's move. Analyze the circuit obtained from the design to determine the effect of the unused states. Right? Analyze the circuit obtained from the design to determine. So the purpose of this question was to actually build a circuit. So let's take out the analyze the circuit part and then we'll get back to it later. So assume the question is that design and draw your combinational circuit. You understand? Perfect. Yes, and as usual, please the chat box is for you. So please text in it, type something in it, and let us. Even if you don't have a question, actually tell us we are doing well or greet us, whatever. But we want to know that you are present. You understand? And the comments too are there. You can text us whatever we want to do, but please give us feedback so that we know that it's going down well with you. You understand? Beautiful. So now let's begin what we have to do, right? We have a state diagram already. So if you remember our steps, all right, we said that the first step, if you remember, is that from your question, right, derive a state diagram or write a state diagram or draw a state diagram. But now we have our state diagram. So step 1 is out. The reduction 2 has been done. So we don't need to reduce again. Usually reduction will be like reduction won't be present. Something that's why I'm not even teaching it to, because it is it's so rare to see something like that, right? I might go over it again, like probably the night before the midterm, but I don't think it's important, right? Yes. Now we have to obtain the state table, the most interesting part of our work right now. Okay, so let's begin. Right. So first of all is our next state table. Next state table, right? You remember what I was saying about your next state table, right? It's a table that tells you what the current state is and what the next state you want it to be is. You understand? Excellent. Oh, okay. So you have a present state, you have a next state. One beautiful thing about it is that, right? So your present states are 3, A not, B not, C not, and your next state is A1, B1, C1. Now look at it though. When we look at 000, 000's next state is dependent on its input, right? If it is 0, it goes to 011. If it is 1, it goes to 100. You understand? Okay, so we get our next state table as 000. You understand? Based on external conditions, our 000 can become, okay, I can become 011 or 100. I believe that was it. Yes, that's correct. Right, now when we get to 011, so the 011 can go to 010 or it can go to 01001. You understand? Wish I could have the diagram beside me. Please hold on. Gosh. Let me get the correct image. Beautiful. I hope you can see it. Yes, you can. Okay, so now this is our diagram now, right? So from 011, 011, right? From 011 we go to 00001, and then we also go to 010. So you do this for everything, right? You do this for all the other 5 remaining conditions. Yes, you do this for all the other 5 remaining conditions. And when you are done with this, right, you'll be able to, let me clean it. Wow, what is going on? Oh, is it different? Sorry about it all. Okay. So now let's get to it, right? If you're able to do your first next state, right, like how I was doing it, then you move on. So now let's talk about the overall state table, because the excitation table, it remains the same for everything, right? Depending on the flip flops you use. This one, did they give us anything? No, they didn't give us any flip flops. So we'll pick the flip flops we want to use. And if they give you any flip flop, and JK is usually the best. It's easiest to remember, it is easiest to draw, there's no complicated anything anywhere. You understand? So please go with the JK state, right? And the excitation table will remain the same regardless of whatever, like whatever you do. Right? It's not like it's going to change. You see, with this one, every next state table would change, but this one doesn't change. So now let's talk about the overall state table. The overall state table, if you remember, we talked about it as present state, right? Then we talked about it as input, the next state, then we talked about it as output, right? Okay, so now we talk about present state being 3, right? Yes, inputs is just x1, and next state 2 is 3. Then the output is also just y out. Right? So we have x in, y out, a1, b1, c1, a naught, b naught, c naught. You understand? That's how we do it. So now we look at it as, so the thing about it is that, look at the diagram again, right? The thing about it is that depending on the input, right, it changes the direction of where it's going to. So how we do this is look at it very well, right? So write 0001. Sorry, 0. Let's start with 0, right? Now what will be A1, B1, and C1? When the input is 1, right, it goes in this direction, it becomes 100, and the output is also 1. You understand? So output becomes 1, and then it becomes 1 0 0, right? So just looking on it, and then you're using to design, right? Hey, wait, oh, relax. Oh, talking about zero. When is zero? When it is zero, you have an output of 0, right? And it's going to 0 1 1. So sorry about that. Yes. So you have 0 1 1, 0 1 1 with an output of 0. You understand? Now you do 0 0 0 1, right? Then it will lead to 1 0 0. So please be looking at the outfits here, right? I remember some of them, so the ones I remember, I'll just do them straight from my mind. 0 0 1 0, and then 0 0 1 1. For the 0 0 1, it is 0 0 1, right? It goes to 1 0 0 when it is 1. It has an output of 1, and then it goes to itself, right, when it is 0. You understand? So you have it as 0 0 1 0. Let me see if there are any questions. No, none so far. Right? Then 1 0 0 1. You understand? Now you have 0 1 0 0 1 0. This is the third one out of the 5 different states that we have in our system. It's becoming too long. Okay, let's still be on it. Have input as 0 and 1, and then we have it as the A becoming 0 0 0 because it returns back to 0. No, it doesn't return back to 0 here. Basically, I hope you know, like, you are realizing what is actually going on, right? You are getting that it's just comparison. You look at the state table, you look at what it tells you, and then you just move. You understand? It is very, very easy to think about if you practice it a lot, right? Yeah, so this is what you do. Let's assume it ends here. Let's assume it ends here because the time is going very, very quickly. Let's assume it ends here. Now, when it ends here, the reason for the K map will come in, right? So you have a next state as A1. So you need to find 3 different things, right? You need to find A1, B1, C1, and then Y out, because you need to build circuits to produce this, right? You have a state table, but you need to build circuits to produce each of them, right? So let's take A1 as first one. Now, when you take A1 as first one, and you realize that you look at it and then you can do SOP, sum of products, right? But if you can do SOP, how do you know that you're getting the most optimum circuit? And that is when you actually do Kana maps. So that's what we'll do right now, right? I'll just do one example, and then I'll see if there are any examples, and then we can move, right? So for this one, we have 4 different inputs, right? We have A naught, B naught, have A naught, we have B naught, we have C naught, and then we have X in. You understand? So for this one, 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Okay, so that gives us this point, right? Okay, so now we have our system, and then this one, right? I want to change the color, right? If you look at it, at A1, this one gives you 1, this one gives you 1, right? And we assume there are only 2 things, so we can move. So we found 1 here. So where is the 1 at? 1 is at 0 0 0 1. So we look for 0 0 and then 0 1, and then we place the 1 here. I hope you understood what I just did, right? A was 0, B was also 0. A was 0. No, this is too dark. Right? A was 0. A naught was 0, B naught was 0, C naught was also 0, and X in was 1. You understand? So A naught is 0 here, B naught is 0 here, C naught is 0, and then X is 1. That's why we placed it in this cell. You understand? Now for the second one, A naught is 0, B naught is 0, C naught is 1, and then X in is also 1, right? So we have A naught being 0, B naught being 0, C naught being 1, and then X in being also 1. So it deserves to be in this cell. You understand? I really hope you are getting it. There are no questions so far too. Okay. So that's what you get simply. Right. Then since we assumed it ends here, it doesn't actually end here. I want you to complete the question, right? Since it doesn't end here, then we'll just circle it. Just put a circle around it and see that, oh, what is changing in this? What is changing? Right. What is changing is C. C changes from C naught bar to C. So that's what is like we'll take out. So A naught, B naught, A naught bar, B naught bar times X in. Now this becomes R, and then we'll see that this is A1. So then we'll build a circuit for A1 like so. A naught, B naught, C naught, X in. And we'll see that A naught is equal to this knotted, this also knotted, and then X in ticking, and then we AND everything. You understand? And this gives you F, the out. This gives you A naught. You understand? And then we feed this into our state register or flip-flops, or this one in this case flip-flops, right? We'll feed it into our flip-flops, and then A1 is actually the what am I saying? So the input of the JK flip-flop. You understand? Okay. Perfect. So that was an example. I want to see if there are any more examples, because this was a very, very quick one, right? So please, that will be the end of our stream. But I'll be putting some questions in the group for everybody to try, and I want you to try your hands on them and like give feedback, so that if we have to do some more tutorials, we would, because I feel like it's the question that we are getting is very, very simple. It's just revision that you would have to do, right? So please go through the tutorial again. If you don't understand that, let me know, and then let me drop some more so that we can quickly have we can do what we need to do to get the 30/30 that we need to do. You understand? Thank you so much for being on the stream, and God bless you. Have a lovely